Hello viewers, welcome to Joseph-Oroks science class. In our previous video, we described the motion of a free falling object dropped from a known height using the four equations of motion. In today's video, we are going to describe the motion of an object projected vertically upwards. Now, let's assume that a boy projects an object vertically upward at 90 degrees to the ground with an initial velocity u, covering a distance, let's say h. Okay, now as this object travels, gravity impacts its upward motion. It slows it down until, let's say, it gets to the maximum height here, where the velocity v, the final velocity v, becomes 0 and the stone returns to the ground. Okay, now we want to describe the motion of this object as it travels upward. Now, in describing the motion of this object, we will want to see how we can calculate the initial velocity, velocity upward, the initial velocity with which the stones travels upward, and also we want to see how we can calculate the total distance traveled by the object, that is the upward distance traveled by the object. Then also we'll see how we can calculate the time taken for the object to get to its maximum height, and also the time taken for the stone to return to the point where it was projected. And at the end of the day, we're going to see that the time taken for the object to get to its maximum height and the time taken for the object to return to the point where it was projected, they are the same. Okay, then we proceed to then find the total time of flight, which is the summation of the time taken to get to its maximum height and the time taken to get for the object to return to where it was projected. Now let's begin by first calculating the initial velocity of the object. Now, in our previous video, I itemized the four equations of motion. So I'm going to make use of the second equation of motion, which I itemized for us in my previous video, which is v squared equal to u squared minus 2gh. Now, in our previous video, the sign here was positive. Now we are now making use of a negative sign. The reason is because, as I said earlier on, gravity g can be negative and it can also be positive. Now the reason why here it is negative is because this object, as it's going up, it's impacted by gravity, and that's what makes it what? To slow down or to decrease. The speed of as this object travels up, its speed decreases. It decreases till it gets to its maximum point, till it then becomes 0. So that is why g here is negative. And also the reason also is because this stone is going against gravity. Because it's going against gravity, gravity tends to pull object downward. Now this object is now going upward, so it's going against gravity, so it's opposing it. So because of that opposition, we denote it by taking it as negative. Now we had said that that at maximum height, at maximum h, v is 0. So if v is 0, we can see here that our initial velocity u squared is equals to 2gh. Now if we make our if we take the square root of both sides, we're going to have that our initial velocity is equals to 2gh, the square root of 2gh. So this is one way of finding the initial velocity of an object that is projected vertically upward. Also, we can also find the initial velocity using the third equation, which is v is equals to u minus gt. Here also we are having a negative sign here. The reason I gave for the first equation here, the same reason also applies here, why g here is also negative. Now at maximum height also, we can see here that v is 0. So if v is 0, so u, our initial velocity, is equals to gt. So we see here that these two equations, we can use them to find the initial velocity of the projected object. Now, this first one, this first equation will be very useful when the height is known. And also, this second equation for calculating the initial velocity will also be very useful when the time is given in the question. So, this is this. Then also, we're going to move forward to see how we can calculate the height. That's to say, the total distance traveled upward by this ball, which is our h. Now, in doing so, we can make use of equation 2, which I've used earlier on today, which is this. So we can calculate our height, and that we're going to use v squared is equals to u squared minus 2gh. And we already know that at max height, that our v is 0. So we see here that u squared is equals to 2gh. Now, if we make our h, which is the height, the subject of the formula, we're going to have u squared, h is equals to u squared all over 2g. So this we can use to calculate the distance traveled upward by the object. And don't forget that the distance covered by the object while traveling upward is the same thing as the distance traveled by the object when returning back to the ground. So the distance does not change. So this calculates the height. Now, also, I want to show to you how we can calculate the time it takes to get to its maximum height. Okay, we want to see how we can calculate for the time it takes for the stone to get to its maximum height. Now, in doing so, we're going to employ the equations. That's the second equation, which we used earlier on in calculating this. So we're going to invoke that. Invoking that in second equation of motion, the third equation of motion, which is v is equals to u minus gt. If we invoke this at maximum height, we see also that v is 0. So if v is 0, so we therefore have that our u is equals to gt. Now, let's call this time taken for this object to get to its maximum height. Let's label it as what? As 1. So tagging it as, let's tag it as t1. Now, tagging it as t1, we can make t1 the sort of formula so that we can have that t1 is equals to u all over g. So this is the time taken for the stone to travel upward to get to its maximum height. Also, we can as well find the time taken for the object to return back to the ground. Now, in doing so, previously in my first video, we calculated the time for an object to fall a distance. That is to say, the time taken for an object to fall to the ground from the point of projection downward. Now, we arrived at that to be, let's label this, let's tag this as t2, as we got in our previous video, we got it as 2h all over g. Now, what is our g here? What is our h here? The h here is a height. That is to say, the distance traveled by the object. And I said earlier on that the distance traveled upward and the distance traveled downward, they are the same. So let's take this h as the distance covered by the object when returning back to the ground, which is u squared all over 2g. We have described that already. Now, if we sub this, or we factor this into this equation, wherever we see h, we factor u squared over 2g, we're going to arrive at t2 is equals to 2u squared all over 2g squared, all in square root. So this will give us u all over g all squared, everything in square root. So this square will cancel the square root. So we're going to have that t2 is equals to u all over g. So we can see here that t1 and t2, they are the same. Okay, time taken to travel upward and the time taken to travel downward is equal, as I've said earlier on today. So we can see here that t1 and t2, they are the same. Now, the last thing we're going to see here is how we can calculate the total time of flight. When I say total time of flight, what I mean by that is the time taken for an object to travel to its maximum height and then return back to the ground again. So that gives us the total time of flight. And what is that? We can infer from here that the total time of flight, which is we can represent that as with t, capital letter T. So total time of flight for this object, which is capital letter T, is equal to T1 plus T2, which is equal to U all over G plus U all over G, which is equals to 2U all over G. So we can infer here that our T, which is equals to 2U over G, is also equals to 2 times T max, which is our time forward for the object to get to its maximum height. So all these equations that I have shown to you since the beginning of this video, these are the equations we can use to perfectly describe the motion of an object that is projected vertically upward. Thank you very much for watching my YouTube videos. Please don't forget to comment, to share, and to subscribe to my YouTube channels. Thank you very much. See you next time. Bye bye.